All right, so let's continue on with the notes and let's look at some examples. So enthalpy. Enthalpy is the energy of a system at a constant pressure. We mostly just ignore that for now because we're not doing anything at different pressures. It is given the unit joules, just like we used before. Remember, 1 joule of energy, so 1 joule equals the amount of energy needed to raise the temperature of 1 milliliter of water. Sorry, it's not 1 joule, it's 4.18 joules. One degree Celsius. So 4.18 joules is the amount of energy needed to raise the temperature of 1 milliliter of water 1 degree Celsius. For chemical reactions, often better to use the kilojoules. Right, 1,000 joules. Right, it takes 4.18 kilojoules of energy to raise the temperature of 1 liter of water 1 degree Celsius. All right, so we've got some. We're going to look at how to write chemical reactions. And I need to find the right one. So a typical exothermic reaction could be written like this. So we've got copper plus chloride producing copper 2 chloride. So copper is Cu plus chlorine diatomic. And we're going to get CuCl2. First thing you do is you balance the chemical reaction. It's 1, 1, 1. Always balance it. We always work with balanced. Now, this is an exothermic reaction, so we give off plus. Now, I don't know the proper number here. We write plus heat on this side. Heat is a product, so it is released. In this, there is a release of, I don't know how much. Let's just throw in a number here. 100 kilojoules. 100 kilojoules of energy. That energy appears on the products side of the reactions. Exothermic reactions release energy because the heat content of the reactants is higher than that of the products. Right? So if I look up here, the reactants have a high energy capacity. This is just energy. Then down here, these guys have less energy, less enthalpy. And some of the rest of the enthalpy is released. Okay, so the reactants have a higher level of energy than this. The excess energy is released to the environment during the reaction. We can capture this energy and measure the temperature change. Like, let's say we can do this reaction underwater. This reaction will happen underwater. That energy will be released into the water, and we can measure the temperature change of the water. And then we can figure out how many joules or kilojoules has been released. We typically indicate that something has decreased by using a negative. We can do the same thing with enthalpy changes. When the amount of enthalpy in a system decreases, delta H equals negative number is used to indicate the drop. So we can rewrite this system like this. 1 Cu plus 1 Cl2 gives us 1 CuCl2. And the delta H the change in enthalpy for this is negative 100 kilojoules. What this negative 100 kilojoules means is that the reactants would have 100 more kilojoules of energy than the products. So if the reactants, just as an example, say the reactants had 350 kilojoules of energy, then the products would have 250 kilojoules of energy. And this other 100 kilojoules of energy was released into the environment. Okay, so that's an exothermic reactions. Now let's look at endothermic reactions. A little bit different, but they should make sense now. Okay, so during endothermic reactions, energy is absorbed from the environment. So energy is gained by the chemicals. A typical endothermic reaction is written with the energy term on the reactant side. So a typical endothermic reaction is written like this one. So we've got carbon plus water plus 133.7 kilojoules of energy will give us carbon monoxide plus hydrogen gas. So the amount of energy here plus this 133.7 kilojoules will give us the amount of energy of these guys. Right? The amount of energy in the carbon and the water plus the 133.7 kilojoules of energy from the environment will give us these guys. The amount of energy in those guys. As with the exothermic reaction, we can remove the energy term from the equation and record the enthalpy change with a delta H positive value, indicating that the enthalpy is increased. So it would look like this. Carbon plus H2O gives us carbon monoxide plus H2. These are all balanced with ones. And our delta H is going to be a positive 133.7 kilojoules. Now, what does this mean? Well, let's just say, for example, if this started out with 200 kilojoules of energy in these two guys, we had to absorb some energy from the environment to get to 333.7 kilojoules for these guys. Where did that extra 133.7 kilojoules of energy come from? From the environment. So in this one, our products have more energy than our reactants. All right, so that's all for the notes. We're going to look at some questions, some examples on how to write these out.